Math 3, Unit 4, Section 3. Today we're talking about adding and subtracting fractions. So, looking here at the top, okay, this is what you learned back in 5th grade, okay? Now, obviously, we're building on this into like our high school, you know, but starting back in 5th grade, you can add fractions that have like denominators. So our denominator here is 7. You add 3 plus 2 together, and you get 5 over 7. You keep the denominator the same, okay? Now, when you're subtracting, we're going to end up learning that we're going to take this minus, and it distributes either to everything on the top or everything on the bottom. Well, we want the denominators to stay the same, so it doesn't usually make sense to distribute the negative to our denominator. So we normally will distribute it up here to the numerator, so that 2 makes that a negative, and then we change that to a plus. So 3 minus 2 ends up making 1, and we keep our denominator the same. So, in general, if you have like denominators, we just add our numerators, a plus b, together, and you keep it over the same denominator. With subtracting, we distribute that negative to that top section, because sometimes there's more than 2 terms there, and you would distribute it to each of them. And same thing, then we can combine them together, so I end up with a minus b over c. Now we're going to practice with our Math 3 fractions, okay? So now we have variables and stuff, okay? Are the denominators the same? Yes. So we will rewrite it, and I always rewrite the denominator so it's there and I don't have to think about it anymore, okay? We keep the denominators the same when we're adding fractions. And then can I add 2a and 3a together? Yes, and that makes 5a. Can I reduce anything here? Absolutely not, okay? Because we know that anything that is adding or subtracting is stuck together like glue, okay? And unless I could factor something out, I cannot reduce this unless I have a 3a minus 4. And I don't have that. So this is my answer. Any questions? Okay, next one. Are my denominators the same? Okay, so I'm going to rewrite it with my denominator. 8c plus 28. We can combine like terms. So notice I have a 3c and another c, which makes a 4c. And then there isn't anything that's also a regular number like this, so we just write minus 14. At this point, how it's written right now, could I reduce anything?
Yes.
Absolutely not. Those are all connected together like glue, and unless they are exactly the same, we cannot cancel them out or reduce them. Okay, now, is there anything on the top that I could figure out, factor out? I could factor out a 2. So I'm going to go ahead and factor out a 2. And if you need to, you could divide each of these by 2 like this so you can visually see what's happening. And what would be left over? Very good. Okay. Over the denominator, I can factor out a 4. Very good. And again, I can divide each of these by 4. And I'm left with what? 2c plus 7. Okay. Are these the same? No, because this is a minus and this is a plus. Now, we've learned that we can factor out a -1 sometimes, and it changes all of the signs. But if I did a negative here, the 2c would be a negative and the 7 would be a negative. And so I can't do anything to make these cancel out. Okay, they are different. Now, can I reduce anything at the front? Yes. So we can divide the top and the bottom by 2. And so the 2 cancels out and 2 goes into 4 2 times. Remember that you have to keep things on the appropriate side. So we keep that 2 in the denominator. So my answer ends up being 2c minus 7 over 2 parentheses 2c plus 7. And we might want to go ahead and keep the top part in parentheses too. Okay, so remember, anything with pluses and minuses, they're all stuck together. You cannot reduce them unless they're exactly the same. Okay, questions on the second one? Okay, next one. Are my denominators the same? Yes. So we're going to go ahead. We're going to rewrite our denominator because we know we don't change that at all. It's the same. Okay? And then we can add the tops together. And can I add n and 2 together? No. So we just write that as n plus 2. The way these are written right now, can I reduce anything?
No.
Very good. No is the correct answer. Okay? Now, could I do anything, though, to maybe see if we could do something? Yes. So this is a trinomial. Okay? 3 terms. We multiply over. So my multiplication number is 4. And my adding number is what? 4. So what numbers will work?
2.
Very good. 2 and 2 is correct. Now, I suggest if you're comfortable using the shortcut, and we can use our shortcut because there isn't a coefficient in front. And so when I rewrite this in factored form, I would write this as n plus 2 times n plus 2, or you could also write that as n plus 2 squared. They both mean the same thing. And on the top I have n plus 2. So can anything cancel?
Yes.
They can't all cancel.
Only be 1 over.
Just 1 for 1, right? And so if there's nothing on top, there is a 1, and then the denominator would be n plus 2. Any questions there? No questions? Okay, so next we're subtracting with like denominators. She's in my, oh, she didn't ever show up there? I was trying to give this to her.
Oh, okay.
Is she in my class? Okay, thanks. All right, so these are like denominators. We're going to keep our denominator the same. Okay, and then this minus sign goes and distributes to everything on the top. There's only one term right there, so that 7 becomes a negative, and then we can now change that to a positive. What is 2 minus 7? Negative 5. Can I reduce anything?
No.
No, because these are stuck together, right? So this is my answer. Okay, again, we have like denominators. So we know our denominator is going to be 10n minus 4. Because this is a subtraction sign, we're going to take that subtraction sign and to distribute it to everything on the top. So the 3n is going to become a negative, and then the 5 is going to become a negative, and then you change that to a plus. 9n and negative 3n become what? 6n. And negative 3 and negative 5 make? Very good. At this point right now, could anything reduce? No is the correct answer because these are all connected together like glue. They're stuck. And unless they're exactly the same, we cannot reduce them. Now, can I factor anything out? What can I factor out?
2.
A 2 from the numerator, and I'm left with? Very good. My denominator, can I factor anything out? A 2. And we divide each of these by 2, and what am I left with? Good. Now, is there anything I can reduce? Very good. The 2's can reduce. Can I reduce anything else?
No.
Yeah, on my desk. So we get 3n minus 4 over 5n minus 2. And again, you might want to keep those in parentheses so that you remind yourself, okay, I cannot cancel out those n's. Okay, they are all stuck together because of that minus sign. It's keeping that as a group. Okay? Are you guys ready to move on? Okay, so last example here with our like denominators. I'm going to rewrite q squared minus 4. And what do I do with that minus sign? Distribute it to the top. Now, I could distribute it to the bottom, but that would not be good because then I wouldn't have like denominators, okay? So we distribute it to the top, we get a minus and a plus, and then we change that to a plus. What is 7q minus 6q? Q. And negative 3 and positive 5 make positive 2. The way these are written right this minute, can I reduce anything? No. Very good. I like that answer. Those are all stuck together, correct? Now, can I do anything else?
Yes.
Yes, I can. Good. These are differences of squares, right? So we're going to rewrite it. We have q squared and a minus, and then 4 is 2 squared. Okay? So our numerator I still have is q plus 2. But my denominator, I'm going to make 2 parentheses, and we start at the left here, and we split those squares apart. So we get a q at the front of each of them. Then I get to the sign. One gets a minus, one gets a plus, and then we split up the 2's. Are there like terms that I can reduce?
Yeah.
The q plus 2's, they're exactly the same, so I can cancel them. If there's nothing left on top, what is there? 1 over. Pay attention. Okay. All right. Any questions here? Okay. So now we're moving on to unlike denominators. Also, I mentioned that this is a little bit long of a lesson. It's 4 pages. Well, like 2 pages front and back. Okay? So we're a fourth of the way done. Okay, here we go. This is the longest page right here. All right. So, first thing, adding expressions with different denominators. These denominators are not the same. Is there something I could do to make them the same?
Yes.
Good. They're opposites, right? And so we can factor out a -1. So if I take a -1 out here, or just a negative, you could think of it as just a negative, this 2 would make it become a negative, and the x would become a, okay. For this problem, I'm going to rewrite this. On your homework, you don't have to keep rewriting each time, but I want you to see what's happening. So when you take that negative out in front there, it basically is making that a minus in front of this fraction. So I still have 3, and then I'm going to flip this around to make x minus 2. So remember that negative, we said we could distribute it to the bottom or we could distribute it to the top. And so it'd make more sense now to take that negative and move it to the top. So we make that a minus, and this becomes a plus. So because this wasn't what we liked, I just factored out a -1. And so I took out a -1 or a negative, which then just changed each of these signs. So if you were, you know what I mean, if we divide a positive by a negative, it makes a negative. If you divide a negative by a negative, it makes a positive. So it just changes those signs. So this minus just kind of goes out in front of the fraction. And then we ended up distributing it to the top. Okay, so my denominator is now the same. They're like denominators. I rewrite my x minus 2. And then what's 5 minus 3?
2.
Can anything reduce here?
No.
Very good. No is the correct answer because all of that's connected together. X minus 2 is stuck together. Right, Noah?
What?
Yeah, exactly. Okay, so this is my answer.
I was looking at it.
Any questions? Okay. Shh. Now, we have these 2 denominators. Are they the same? No. So start by looking at just the numbers in front. So if I look at 5 and 3, they don't have anything in common. And when the numbers don't have anything in common, we just end up multiplying them together. And so I would end up with what number? 15. So what I like to do is rewrite each of the fractions and put the common denominator I want. Whoever has the whistle, please stop doing that. Okay. So these are 15s. Now we look at our m's. this is m to the 5th, and this is m to the 2nd. You need to have at least as much as your highest exponent. And so I can't make 5 smaller, but I can multiply and make this 2 into a 5. Does that make sense? And so that means that the denominator would end up needing to be m to the what power? To the 5th. Okay? Because if I multiply this by m to the 3rd, you add exponents and you end up with 5. Okay? So now that I have my common denominators, I now need to figure out, well, what would I multiply 5 by in order to get 15? 3. And then do you see how this is already m to the 5th? I don't need to multiply by any m's. So all I need to do is multiply by a 3. But whatever we do to the bottom, we also have to do to the top. Okay? The reason is what is 3 over 3 really? 1. When you're multiplying by 1, you're not really changing anything. So all we're doing is making an equivalent fraction. So whatever we multiply to the bottom, we have to do to the top, because really that means I'm only multiplying by 1. Okay? And so 3 times 2 ends up making 6. Okay? Now on this fraction, 3 times what made 15? 5. And then in order to make m to the 5th, I need m to the 3rd. Because when you're multiplying, this would be m times m, and this will be m times m times m, and you'd add them together, and it would make m to the 5th. So when you're multiplying, you're adding exponents. So I need 3 to make it 5. But whatever I do to the bottom, I also do to the top, because that means I'm really just multiplying by 1. Okay, these reduce to be 1. Okay, so we multiply and we end up getting 35 m to the 3rd. Okay, now that we have like denominators, we are going to keep our denominator of 15 m to the 5th. I can't add these together, but what I suggest is that you write them in descending order, because if you were going to factor, you'd want them in descending order. And so that means I'd write 35 m to the 3rd first plus 6. Now, if you wrote it as 6 plus 35 m to the 3rd, I am not going to mark you wrong. It's totally fine. It's just being more proper to write it in descending order. Okay? Now, I can't factor anything out. Those are stuck together like glue. Nothing will reduce. That is my final answer. Do we have questions on that one? Okay, next one. Remember that these are stuck together like glue. So this is m plus 2, and this is m minus 7, and they don't have really anything in common except for they're both m's, but in terms of making a common denominator, you're going to need an m plus 2, and you're also going to need an m minus 7, okay? So I'm going to rewrite this with 2 fractions, and my denominators on both of those are going to be m plus 2, m minus 7. Okay. Is everybody okay with that? So if you look at this first fraction right here, what is it missing? What do we need to multiply in order to make it the m plus 2 and the m minus 7? We need an m minus 7. And whatever I do to the bottom, I also have to do to the top, because this really means I'm just multiplying by 1. Okay, now this is m minus 7 times 9. So to make your life easier, you're going to go ahead and distribute the 9 through to both of those terms. So we go 9 times m, which is, and then 9 times negative 7 makes negative 63. Okay, this fraction. So again, we want it to be m plus 2 times m minus 7. So what's it missing? M plus 2. And whatever we do at the bottom, we also have to do to the top, because this really would reduce to be 1, and so I'm really only multiplying by 1. We go 8 times m, which is 8m, and 8 times 2, which is 16. Okay, so now we have like denominators, and we can add our numerators together. So I rewrite this with my denominator, m plus 2, m minus 7. And then we can add the m's together, which makes what? 17m. And negative 63 and positive 16 makes negative 47. Can I factor anything out of the top? Nope. So that's my answer. Because remember, those are stuck together. Nothing is like in parentheses, so I can't reduce anything. All right. Are we feeling okay about this? Yes? Some of you know? Okay, here we go. Now we're just going to deal with subtracting. So it's pretty much the same as addition. We just end up having distribute a negative, right? So looking at our denominators, 5 and 10 have 5 in common, correct? And so what could I do to 5 in order to make it 10? Multiply by 2. So we know our number is going to end up being 10. And then how many h's will I need for my denominator?
2.
2. So it's going to end up being 10h squared. Oops. Sorry. Okay. Are we good with that? So when you look at the first term, do I have to do anything to this 10h squared in order to make it 10h squared? No. So since they're already the same, we just rewrite the 3 there on top. We didn't have to multiply by anything. Okay. Now, on 5h, what do I have to multiply that by in order to make it 10h squared? 2 and then h. Good. Because we need 2 h's in order to make h squared, correct? And then whatever I do at the bottom, I also have to do to the, because this really means I'm multiplying by 1. Okay, we're making it an equivalent fraction. Okay, 4 times 2h is 8h. Now, what do I do with that minus sign? Distribute it, but there's really just that one term, so that becomes negative 8h, and I make this a positive. I would try to write things always in descending order, so I'm going to write my answer as negative 8h plus 3 over 10h squared. If you wrote it as 3 minus 8h, that is okay. Can I reduce anything? No. Because those are connected, right? They're stuck together with glue. All right. Any questions?
Yes.
Do you know what they are? Okay.
My head's overloaded.
Okay, next one. This x plus 3, those are connected together. So this x plus 3 and this x by itself are completely different. Because anything that has adding and subtracting is like one thing. Okay? So, do you know what my denominator would be? It'll be x times x plus 3. Okay? So, remember, this x plus 3 is stuck together like glue. The x and the 3, because this is saying x plus 3, it's completely different than a plain x. Okay? For instance, if you, let's say x was 5, okay? What is 5 plus 3? 8. And then this would be a 5. Do 5 and 8 have anything in common? No. We would end up making it a 40, right? For a common denominator, if I had said x equaled 5. And so because you have a plus 3, that is completely different than a plain x. So just remember, anything with pluses or minuses are stuck together and they're totally different from everything else, okay? So, on that first fraction, what am I missing? What would I need in order to make it x times x plus 3? An x plus 3. So that means I have to multiply the bottom and the top by x plus 3. Because that now makes it x times x plus 3. Okay, and then what am I going to do? Distribute. 11 times x is? And 11 times 3 is? Good. Okay, and what am I missing on the second fraction in order to make it x times x plus 3? x. And so we're going to multiply the top and the bottom by x. And 4 times x is? And then what do we do with our minus sign? Good. Distribute it to the top. This becomes a minus and this becomes a plus. Okay, go ahead and finish that one real quick.
What happened?
Oh, you got 3.
Make sure you watch this. All right. So what did you guys get? Good. 7x plus 33 over x times x plus 3. Okay. Can I reduce anything? No. These are stuck together. These are stuck together. Here's a plain x. Nothing can reduce. They are all stuck. Okay. Any questions? All right. Next fraction. If you have a whole number, what's the denominator? 1. So you can always put any whole number as a fraction by putting it over 1. Okay. What do you think the common denominator for this will be? 3c minus 1. You could put a 1 in front of here, but is 1 times 3c minus 1 still going to just make it 3c minus 1? Yeah. So because of that 1, you don't have to worry about it, but if you want to write it, you totally can. If this was a 2, though, you would need the 2. Okay? So 3c minus 1. Did I do anything to change this one? Do I need... It's already 3c minus 1, correct? Yeah. So we just rewrite c plus 2. This right now is a 1. So what would I need to multiply it by in order to make it 3c minus 1? 3c minus 1. Okay? And whatever we do at the bottom, we also do to the... Okay? And what should I do now? Distribute. 5 times 3c is? Okay, and 5 times negative 1 is? And if you already did it as a negative, it's fine, you're going to get the same thing. I'm now going to, because I have that minus sign, what am I going to do? Distribute it? Yeah. So this will become a minus, and this will become a plus. Some of you distributed negative 5, which was fine, and then you would just make that a plus. Okay. So keep our denominator of 3c minus 1, and then c and negative 15c make what? Good, negative 14c, and 2 and 5 make 7. Can I factor or do anything? What can I do? Take out a negative 7. And I would suggest always taking out a negative 7 when that first term is a negative. You want to take that negative out. So when I divide this by negative 7 and this by negative 7, what do I end up with?
2c minus 1.
Okay. Does that, can I reduce that? No. Why not?
Because they're stuck together.
They're stuck together and they are not exactly the same. They look a lot alike, but they're not the same. That's my answer. Okay. Moving on. We're really more than halfway done, okay? Lots of practice here. Here we go. So, these are stuck together, and these are stuck together. They are not like denominators. Carrie, you got this? Okay. So, we want to factor this. So we multiply over. My multiplication number is what?
1.
My adding number is 2. What numbers will work? 1 and 1. 1 times 1 is 1. 1 plus 1 is 2. Since these are the same, okay, and since there's no coefficient in front, we can write this either as x plus 1 times x plus 1, or we could have written that as x plus 1 squared. Do you remember back to when we were dealing with the m's, we had to take at least the largest exponent? Do you guys remember that? Yes? So what do you think our common denominator is going to be over here? X plus 1 squared. Because this one has two x plus 1s, our denominator has to have at least two x plus 1s. If you would rather write it out as x plus 1 times x plus 1, that's fine. You can write it as a square or write it twice. Okay, so this first fraction, what is it missing? It's missing an x plus 1. Do we agree with that? So whatever we do to the bottom, we also have to do to the top. Okay? Because this means we're really just multiplying by 1. Okay, what should I do now? Distribute. 3 times x is, and 3 times 1 is 3. What about this one? Do I need to do anything?
No.
So it's just a 1. Okay, so now we are going to keep our denominator, which is x plus 1 squared. 3x doesn't have anything, so we just write 3x, and then 3 plus 1 is 4. Can I factor or do anything to this?
No.
Okay, and because as a plus, it's stuck together. And can I reduce anything here?
No.
Absolutely not. Good. There's your answer.
How did you get the square for the other one?
Do you see how these are both x plus 1s? So that means you have x plus 1 squared. They're exactly the same, so instead of writing it twice, you can write it as a square. So this already had an x plus 1, and so I needed one more. So that's why I multiplied it to the top and the bottom. And then since you have 2 now, it's now a square. Okay? Shh. All right, any other questions on this problem? Okay, next one. So right now, all of these are stuck together. They are not the same. What should I do? Factor them. Okay, factor them. 4 is actually what? 2 squared. So if I factor x squared minus 2 squared, I make my parentheses. I split up the x squared, which gives me an x and an x. Next is my sign, which means one's going to get a, and one gets a plus. And then I had 2 squared, so I split those up, and each one gets a 2. Okay, now I go here. How do I factor this one? Good, we multiply. So what is my multiplication number? 2. What is my adding number? 3. Which numbers will work? Very good. These multiply to make a positive, but when you add them, they make a. So that means we get x minus 2 and x minus 1. Okay, so I'm going to give you 1 minute right now in your groups, and I want you to see, based on what we've done here, what you think the common denominator is going to be. How many sets of parentheses are you going to have in the denominator? 3 is the correct answer. So, do you see how these each have an x minus 2? Okay, so we're going to write an x minus 2. Okay? This has an x plus 2, so that means we have to have an x plus 2. This has an x minus 1, which means we have to have an x minus 1. So anything that's the same is fine. You can just write that once. Unless like here we had, because there was 2 of them, we had to write 2 of them. Okay? So that ends up being my common denominator. So x minus 2, x plus 2, and x minus 1. Anything that's in a denominator has to stay in the denominator. But if they share something, you only have to write it the one time. Okay. So if we go back to this first fraction, what am I missing? x minus 1. So I'd have to multiply the denominator by x minus 1 in order to get this. And whatever I do to the denominator, I also have to do to the numerator or top. Okay? So we're going to distribute this. 3 times x is? 3 times negative 1 is? Okay. Next fraction. What am I missing? What do I need in order to make it my common denominator? I need an x plus 2, and whatever I do to the bottom, I also have to do to the top, because that means I'm really just multiplying by 1. Okay, 4 times x is? 4 times 2 is? 8. And then what do I do? Very good. Distribute that negative. So we get a minus here and a minus here, which makes this now a plus. Okay, 3x and negative 4x makes what? Negative 1x, or just negative x. And negative 3 and negative 8 make a? Very good. And it's over x minus 2, x plus 2, x minus 1. Could I factor anything out or do anything with this in order to match it with something down here? No. Could you factor out a negative 1 though? Yes. So you don't have to, but you could. So if you did, you'd get negative 1, and then it's x plus 11, and then you have your same denominator that we already had. Okay. You don't have to do it this way though if you know nothing's going to cancel out. All right, do we have any questions here? Yes. X minus 2 squared. Because, so you know how like when we had like 1 over 5 plus 1 over 10? 10 is really 5 times 2. So for our denominator, we just took a 5 and then we also took a 2. So because these each have x minus 2's, it's just like they each had a 5. So you only have to write the x minus 2 once, since they each just have a x minus 2. The reason why we had to have 2 on this one is because this one had 2 of them. Right. Okay? All right, any other questions right now? Okay, remember that these are connected. This time, see there are 3 terms. You are going to see a question just like this on your test. Make a star by it. Make sure you get this. Okay? Now, this is connected like glue. So, in my denominator, what am I going to need for sure? An x minus 3. This next part is where people mess up. Okay? This is an x to the third, and this is an x. What is the greatest amount we are going to need?
X.
X to the third.
To the third.
We can't change x to the third smaller, but we can multiply the top and the bottom by an x squared and make this x to the third. So, and I'm going to write this in front here. If you didn't, that's okay. We just normally have anything that's like just a plain x at the front, and then, okay. So this is our common denominator. X to the third and x minus 3. Notice that these were options I could have used. X to the third and x minus 3. Okay, now, on this first fraction, what am I missing in order to make it x to the third and x minus 3?
X to the third.
So that means we would be multiplying this top and the bottom by x to the third. So guess what we need right here? X to the third. Okay. What am I missing on this second term?
X minus 3.
Good. I would need to do x minus 3 to both the top and the bottom, correct? And so next to this 7, guess what I'm going to write?
X minus 21.
No. I'm going to write x minus 3 because they have that 7 right here.
Oh, yeah. I'm sure.
So we normally would distribute it. It's just pre-distributing, okay? We're basically writing what we would write right here. Okay. This last one, what are we missing? X squared and
X minus 3.
because we already have an x, right? So we just need 2 more. So this should be x squared and x minus 3. And that's it. Like, this answer on the test is you writing that stuff in.
That's it?
That's it.
Oh, yeah.
Okay.
That I can do.
All right. Do we have any questions there? Okay. This last part looks complicated, and it's called complex fractions, but it is not complicated. Okay. Here we go. I'm going to give you a couple steps. Okay? Step 1. Find the LCD. What does that mean? If you don't know what that means, I'm going to write it here. Least common denominator. Okay, so find the LCD of the entire problem. So, what I mean by that, I'm going to show you right now. We're looking at this problem. Here's a denominator. In fact, I'm just going to highlight them real quick. So we have a 2, an x, and a 2. Those are all my denominators. So what would be the LCD for this problem? What would be my common denominator for this problem? 2x is the correct answer. Okay? So that is step 1. Find the LCD of the entire problem. Okay. Step 2. Multiply every term by the LCD in order to eliminate double fractions. Okay, so we're going to do that step now, but I'm going to wait till you finish writing. So what do I mean by that? We are going to go to every single fraction in this problem, and I'm going to multiply it by that LCD. So I'm going to put a 2x right here, and it goes to the top part when you're multiplying it, okay? So 2x, I'm going down here, I'm multiplying by a 2x, and here I'm multiplying by a 2x. So do you see how I'm going to every single term in the problem and multiplying it by 2x? Okay? And then step 3 is reduce. Okay. What do I mean by reduce? What I mean is, see here, this 2 and this 2 can eliminate. Okay? And you're left with what's here, which is x times 1, which makes x. Okay? And then I have a plus sign. I'm going to go here and reduce. What happens? The x's cancel out, and I'm left with 5 times 2, which is 10. Over. What happens here? X's cancel out, and we're left with 2 times 3, which is 6. This has a minus sign. And 2's cancel out, and 7 times x is. If you could factor and simplify this more, you would. And so the last step I'm going to do is, factor / simplify if possible. For this problem, could I factor or take anything out in order to simplify? No. So that's my answer. It's done. Okay. So we're going to do one more and then we're done. Okay. So step 1, find the LCD of the entire problem. So if you need to go through and highlight all of your denominators, I only have really 2 denominators, but I'm going to make these have denominators, but I'm just going to put them over 1. Okay, so what is my LCD for this problem? What is my common denominator? b squared is correct. Because remember, you need at least b squared for your denominators, because we could multiply this one by a b and make it a b squared. Okay? So b squared. So now we are going to go to step 2. Multiply every term by the LCD in order to eliminate double fractions. So that means we go to every term and we are multiplying by b squared. Okay, everybody see that? Bless you. Okay, I'm going to move this up now so we can see this a little better. Okay, and now step 3 is reduce. Do I reduce anything? Does 1 reduce with anything? No. So I just multiply those together, but I'd write them in order. And so that is AB squared. Plus sign. Now what?
A squared.
No. So here's a B and here's a B squared. What do I do?
Oh, take away a b.
Good. So we reduce. 1b goes away, and this is going to, because 2 minus 1, because right, this has an exponent of 1, 2 minus 1 is 1, and it stays on the side of the bigger exponent. And so that means I'm left with what?
AB.
AB. Okay. Now I'm going to the denominator. Can anything reduce on that first one? Nope. So I'm just left with
B squared.
minus, and then what happens with the next term?
1.
They all cancel out, and we're left with 1. Okay, so then it says factor / simplify if possible. Can I factor anything out here? Do they have anything in like?
No.
They have an A in common, and they also have a. So I'm going to factor out AB, which means I'm dividing each of these by AB. For something like this, it might make more sense to see it like this. The A's cancel, and B squared divided by B is what? B. Plus, what happens here? Cancels out, and we're left with 1. Over. This says B squared minus 1. Can that be factored?
Yes.
Because 1 is really
A factor.
a square, right? 1 squared? 1 squared is 1. So we make our 2 parentheses. We give each of the parentheses a B. 1 gets a minus, 1 gets a,
Positive.
and then each of them get a.
1.
Is anything exactly the same that I could reduce?
Sharing.
And so my answer is AB over B minus 1. Could I cancel out those B's? No. Very good, because those are connected like glue. B minus 1 is stuck together. Any questions? No.